Roller measurement kits. We found that in today's economy, customers are trying to find ways to cut spending and maintain their existing equipment for as long as they can, and as economically as they can. For years, we've provided services to help in measuring, specifying, and even troubleshooting the rollers and roller challenges that customers come to us with. These are the tools that our engineers utilize when measuring rollers. We recommend you utilize a similar set of tools by getting one of our roller measurement kits. As we walk through the measurement program, we'll touch base on every one of these tools and explain how each one is used during the measuring process. Don't have time to send Omni a sample roller? Omni offers toolkits and user guides to help you measure your own rollers in the field. Our customer service staff can also guide you through using the tools to find the information you'll need for a roller quote. Identifying roller style. Gravity rollers have no drive options. Grooved rollers have one or more grooves formed into the tube and are driven with urethane bands. Sprocketed rollers or powered rollers have one or more sprockets welded to the tube and are driven with chain. Identifying roller assembly. Crimped versus press fit. Crimped roller assemblies. Crimped rollers have the end of the tube deformed to hold the bearing in. Bearings installed in this manner are non-replaceable. Press fit roller assemblies. A press fit roller has a tube which is not deformed and it's still straight. The tube is straight because it is counterbored to the correct inside diameter for the bearing to fit. Identifying axle retention. On spring-retained rollers, the axles will push in on one end. Fixed rollers do not have this feature. On pin-retained rollers, the axle can be completely removed and will usually include a pin with a hole on the other end, typically either being a cotter pin or a hog ring. In addition, if the axle looks to have any machining done, reference our axle machining reference drawings in your guide. Measuring between frame, or the BF. Use your tape measure to measure the distance between the inside of the frame to get the BF, or between frame dimension. Do not measure on the outer edge of the frames or measure the roller. Place your tape measure against the inside of the frame and read the measurement at the inside of the opposite frame. It's good to take at least 3 measurements to make sure that your frame is not bent. Measuring overall cone, or OAC. The overall cone measurement is from the outermost portion of the bearing. Place the angle flat against the outermost part of the bearing, not against the flange of the bearing and not against the tube. Slide it along the axle until it stops. Place the angles flat against the outermost bearing extension on each end and measure between the two angles. Utilizing the angles to provide a straight vertical edge to measure from makes things much easier. You'll see here that it's easy to hold the angle steady by holding it with your left hand as you hold the end of your tape measure. Add 1/8 inch to the overall cone, or OAC, to get the between frame width, or the BF. Measuring overall cone for rollers 6 inches or less with chocks. Short rollers may only need 1 chock. As with other rollers, place the angles flat against the outermost bearing extension on each end and measure between the two angles. Measuring the overall cone for rollers 6 inches or less with calipers. If the roller is short enough, you can simply use the calipers. Measuring the outside diameter. Place your caliper around the tube. Hold it snugly but not too tight. Make sure you hold the caliper forks at an angle at the widest part of the roller. In measuring large diameter rollers, you may find that the forks the caliper forks are too short. In this instance, you will need to measure from the top, allowing those forks to crisscross the widest point of the tube. Measuring tube thickness. If you can get the bearing out, use the calipers measuring the thickness of the tube from the end. Now this is a bored tube, as you can see the seat at the back of the bore. So by measuring the thickness, you get the thickness of the material after it's been bored. Most likely, determining the exact tube thickness will not be as vital as knowing what the application is to ensure that the roller will withstand the environment and handle the product being transferred. Identifying tube material. Tube material can be identified by appearance and by utilizing a magnet. PVC. PVC is a plastic and can be white, yellow, or a multiple of different colors. Aluminum. Aluminum has a dull silver finish and the magnet will not stick to it. Aluminum tends to have very fine, long lines that run the length of the tube. Aluminum is also lightweight and soft compared to other metal materials. Mild steel. Mild steel will usually have a weld seam and a dull finish, and your magnet will stick to it. Pipe. Pipe will have a varnish over it. The magnet will also stick to pipe, and it will have a relatively rough, gritty appearance. Galvanized steel. Galvanized steel will have a mottled finish look to it, and it is coated with a thin layer of zinc, giving it a shining appearance. Galvanized steel also has a scaly or textured look to it. Stainless steel. Stainless steel will have a bright silvery finish. The magnet will not stick to it. Powder coat. Powder coat will be a color and will feel like plastic. The magnet will stick to it if it is steel underneath. Measuring axle length. Place the angles against the ends of the axle. Use your tape measure to measure between them. This will give you the axle length. Most standard rollers come with a standard axle length, but it is important to measure the axle because different manufacturers may have different standards, or it could be a custom length. Measuring axle extensions. If using a tape measure, place it at the end of the bearing and measure to the end of the axle. If you're using the caliper depth gauge, rest the end of the depth gauge on the end of the bearing and push the body of the calipers down until the ruler touches the end of the axle, giving you a measurement. Measuring the axle size. Again, utilizing the calipers, place the forks on the flats of the hex, not across the points. Once you have your axle measurement, convert it to a fraction to identify the size. Due to steel tolerances, the decimals may be slightly off. For round axles, simply measure the diameter. Measuring sprockets. Most sprockets will have the size stamped on the sides, making it very easy to know the size of the sprocket needed. If there are no markings on the sprockets, you can use chain samples by placing them over the sprockets to determine which one fits. We provide our standard sizes in our kit, 40, 50, 60, and 80 chain. Measuring sprockets using chain samples. Here is an example of chain that does not fit correctly. Here is an example of one that does fit correctly. Here you will see the teeth fit through the chain correctly. Measuring sprockets without chain samples. If you don't have chain samples, you can measure the chain pitch and sprocket width to determine the sprocket size. Using the calipers to measure sprocket width. Use the calipers to measure the sprocket width. We will need the width of the other sprocket as well. Using the calipers to measure chain pitch. Measure from center to center of where the chain roller would set between the teeth. Line up the calipers with the centers or bottom of the sprocket teeth. Using the tape measure to measure chain pitch. When using the tape measure, the easiest way is to use a line past the guard. Line up that line with the center and measure to the line that falls at the next sprocket center. Utilize the chart to determine the sprocket size by using the chain pitch and sprocket width measurements. Counting sprocket teeth. A quick, easy way to help identify the sprocket is to simply count the teeth on the sprocket. The number of teeth can help to identify the basics of that sprocket. Measuring sprocket locations. Using the calipers and the tape measure to measure sprocket locations, place the angle against the face of the bearing closest to the sprocket and use the tape measure to measure from the angle to the center of the closest sprocket, and this would be our preferred method. For each additional sprockets, use the tape measure to measure from the center of one sprocket to the center of the next, or measure to the edge of the sprocket. If you are going to measure to the edge of the sprocket, you will need to get the width of the sprocket so we then can determine the center. You will also need to get the measurement between the sprockets so we can determine the spacing. And we will need the width of the other sprocket as well. If you're only using the tape measure and you feel comfortable, using the angle, measure from the face of the bearing to the center line of each sprocket. Measuring groove outside diameter. Place the forks of the calipers at the center of the groove to get the diameter of the groove. Once you have the groove diameter and the roller diameter, use the following equation to get the groove depth. Tube diameter minus groove diameter divided by 2. Measuring groove width. Line up the caliper forks with the edges of the groove to get an estimated measurement. It is best to know what size O-rings are being used in the groove if you have one. If not, add your groove width and groove depth measurements to get the O-ring size. Measuring groove locations. Use the angle to create a flat surface to measure from at the end of the bearing. Use the tape measure to measure from the angle to the center line of each groove. Keep in mind that measuring grooves and groove locations is not a precise science due to belt stretching and groove wear. Identifying bearing features. Identifying bearing markings. Some bearings may have manufacturers' names or part numbers stamped on them. Identifying unground bearings without seals or shields. With plain, open bearings, you can see the balls between the inner and outer race. As you move the bearing, you can see the balls moving. Identifying sealed bearings. With sealed bearings, you can sometimes see a black, blue, or red colored seal in front of the balls. Identifying shielded bearings. Shields will have a metal cover over the balls between the inner and outer races. Sometimes you will be able to see the plastic or rubber seal. Identifying bearing styles. There are many categories and styles of bearings, of which we have multiple options. One test to determine the style of bearings is to spin it. If you can hear the balls in the bearing moving around and the spin is not very smooth, it is most likely an unground or non-precision bearing. If it spins smoother and the balls are not colliding into each other, then it is most likely a semi-precision or precision bearing. At this time, you can also tell the difference between oiled and grease-packed bearings. Grease-packed bearings do not rotate as easily as a free-spinning oiled bearing. This is because of the increased rolling resistance the grease creates. The following are samples of these different styles, as well as oiled or grease-packed. Plastic bearings with stainless steel balls. Oiled, unground bearings. Grease-packed, unground bearings. Oil, semi-precision bearings. Grease-packed polypropylene housed ABEC 1 precision bearings. Oiled polypropylene housed ABEC 1 precision bearings. UHMW Bushing.